Thank you all for coming and to my talk today. This is my second time here at NDC Security. It's been a couple years. My first time was actually one of my first international talks a couple years ago, where I talked about secure infrastructure as code and integrating that into your pipelines. Today I want to talk about the MITRE attack for developers. And a lot of people that talk about this, a lot of people talk about MITRE, talk about kind of like the grid line about how attackers will approach and operate against you. So my name is Chris Ayers. There we go. I'm a principal software engineer at Microsoft. I actually just got promoted this week, so that's nice. I've been there a number of years, but I'm on the socials, I blog, and this talk, all my other talks, you'll find out actually on GitHub. I do everything out in the open, so I have samples, I have all my slides are in Markdown. This is actually a web page that I'm displaying off of GitHub pages, so like all my slides are kind of evergreen, and so you can always get this information whenever you want. Feel free to reach out and connect. But I kind of want to talk about the security challenge that developers face. You know, we're having to put on all sorts of hats. Be it learning cloud architecture and infrastructure and testing and security, like there's just always another hat. And I want to talk a little bit about OWASP as well. OWASP is important, and that really complements MITRE. And we'll dive into MITRE, and we'll talk about some primary things with some code samples. Like, we've made the attack surface explode over the years. Who's doing microservices? Who's doing containers? So we've got all sorts of bits running, endpoints everywhere. We're now throwing in MCP, and we're throwing in AI agents. So we just have this explosion of places where we can be attacked. And the attackers are getting more sophisticated. They're not, 96 movie hackers where we're just trying to have fun with each other. We've got nation state actors. We've got corporate espionage. We've got all sorts of different things that are going and different motivations to attack your software for different reasons. Maybe it's a botnet. Maybe it's Bitcoin mining. Maybe it's data. And we've seen over these past few years more complex attack scenarios, more interesting ways that they're coming at us that we haven't thought of before. And we'll touch on some of those. And a lot of our defenses, we go, well, we've hit the OWASP top 10, we're good. Or we've got a WAF, we got a firewall, we're good. We're using identities, managed identities, we're good. We can't do single point of defense. We have to do layered defense. We have to do lots of different things. So, and just because we're doing a lot more with AI, so are attackers as well. We just need to think through that. So, OWASP, there's a booth out there, 25 years. The Open Web Application Security Project. The top 25 they've been doing for quite a while, and there's always a couple of recurring players in there, like cross-site scripting, SQL injection, identity. Like we see a lot of the same problems over and over and over again. Like this is not a solved thing. Like we wouldn't have the same things on the top 10 every year if it was a solved thing. Who's seen SQL injection like every year of their career since they've been in? See, like, this is a good old Bobby Tables, right? I mean, only related to Bobby and Nora all previous instructions. Like, they're cousins. But this is a really good way of looking at your vulnerabilities in your code base. This is a good way to classify things. There's remediation guidance on how to handle it. Like, it's a good, focus on how to prevent it. But it's not the whole picture. This really is what can break in your application, but it's not how attackers think. So MITRE actually comes from the Fort Meade experiment. This is, US government, intelligence organization type stuff that had some precursors to it. It's a public corporation, but there was some US government funding. I don't want to talk about politics. As a Florida man, born and raised in Florida, yeah, I don't want to talk about politics. So, but it's a knowledge base of adversarial tactics. Like it, and we'll go into it a little bit more, but it's tactics, techniques, procedures, ways they interact with your application. Not necessarily the specific line of code or the specific vulnerability, but the patterns and techniques that they're using. And it's classified with like 14 different tactics. There's like 200 and something techniques, and they have different terms and numbers for each one, IDs, that you can reference. And if you go around some security researchers, if you're a dev, and you say some of these techniques, they go, oh yeah, they know exactly what you're talking about. This is like the same thing if you're a dev and you talk about an incident, that might mean my app is down. But if you say incident to a security person, they're like, oh my God, what got breached? Like, the words matter, and so this is important. But this is based on real data, real threat intelligence, real attacks, real breaches, and it's really how they operate. Now, MITRE itself has a lot of different things in it, including weakness databases, there's attack patterns in KPAC, there's the CVE database. Who's heard of CVEs? You see them all over GitHub. You see them all over every organization, the critical vulnerabilities. We've got attack, so the tactics. There's some other ones, like Atlas for AI and ML, and defend with countermeasures. And I'm not going to go into all of these, but they all kind of fit into a general theme of here are some techniques and things to be aware of to classify what's happening. Now, attack really is the tactics, the why of the attack. What are they doing? Like when they're doing an activity. Maybe it's initial access. Maybe it's persistence, like they're trying to get in or stay in. What are the techniques they're using? Like they're phishing or spear phishing, or they're doing brute force. Like that might be the technique. And then there might be sub-techniques. So spear phishing via email. All of these are the way attackers think. So it's not necessarily a vulnerability in your software if someone's trying to spear phish, but it's a vulnerability in the whole system and how you might get breached by an attacker. And there's a lot of real-world examples on how these procedures work. So you can think of these tactics kind of in 4 columns. There's the pre-attack. So maybe they're doing reconnaissance. They're trying to learn about your system, learn about your team. Maybe they're looking at your job board and looking at your tech stack on what you're hiring for. That tells them information. Maybe they're looking at the error messages that come back from your website. If you're not properly scrubbing them, that might tell them information about your specific versions and things. Maybe they're doing resource development. They're like trying to build out resources to get in to your systems. Once they get in, maybe they're trying to get that initial access. They're trying to go for the compromise, get access in some way, find a way to execute, and stick around with persistence, and like escalate their privileges from I have a normal user identity up to an administrative identity. Now that they've kind of gotten in and done a little bit of work, they want to try to stay in. How can they avoid being detected? Maybe through log evasion or credential access. Can they move to other systems inside your network? Remember the good old 3-tier, we've got a DMZ and we're fine, just put the web servers in the DMZ and we don't need to scan a lot behind that firewall because nobody will get in. That worked well for all sorts of big corporations, right? Once you get behind that firewall, it's like the soft, juicy underbelly. So, and then what are they doing in there? Are they doing command and control? Are they exfiltrating data? Are they just stealing credit card information or PII? Like, who knows what it's for? Maybe it's mining or botnet. But these are like the tactic areas that they go for in a lot of ways. And this is where OWASP and attack kind of differ a little bit. OWASP focuses on those vulnerabilities in the code and like what can break in your code. Like it's more of a prevention thing. And it's a box you can check. Did I check for SQL? Did I do for this? When you're looking for it, right then. So it's the application layer. But MITRE goes throughout it. Oh, somebody tailgated into a building and dropped a USB drive. We were just talking about this earlier on device vulnerability. It's like, what would I do to prevent a device attack? And I went, well, did someone leave their laptop logged in and get coffee? Do I have enough time to load a web page or execute a thing? Or could I drop a flash drive in their network and hopefully someone plugs in or plug in a router that emulates their Wi-Fi? Like all of these things are possible, but can I just poke around their website? Can I brute force? There's all sorts of different things. So there's this, what attackers do. And a lot of what you want to try to do is detect it. What are the behaviors that you can detect that will alert you that something's happening? I don't think a lot of us do enough logging and alerting in a way that tells us, oh, someone's trying to log in 10,000 times in 5 minutes. So, together, we have a better picture. It's prevention with detection, it is vulnerabilities and how the adversaries behave. We get the defense in depth, we can look at vulnerability chains. So it's not just, oh, they use SQL injection. It's, oh, they use that to do privilege escalation to then get into this system, and then they use that to get this other thing. We can think through why are they doing these activities. And we can map them. So you'll see like IDs like this, like T1078, valid accounts. Cool. That's really hard to protect against. This is someone's valid account. Well, how did they get that? Maybe they spearphished. Maybe they put a keylogger on. Maybe they were sitting over their shoulder at the coffee shop watching them log in, and it's valid credentials. That's hard to protect against. That's real hard to protect against. But maybe account manipulation is something we can look at. You can't elevate yourself. You know? So as you start looking through these, you know, injection, like taking advantage of your public-facing application, you know, through fuzzing or whatever, maybe executing commands. I'm going to show some examples of these, but you can see how the OWASP category can map to some of these MITRE techniques. They overlap and they complement each other, and they give you a more holistic picture of what's happening with these attackers to take advantage of these vulnerabilities. So let's think like attackers for a minute. So when you think like a defender or a developer, who's sort of the happy path, the golden path, right? Hey, if we put this block in place, they won't be able to do it. So it's just going to be a straight line, and if we block each thing, they'll never get through. But attackers might move in different directions, move laterally, loop back, try a different thing, get into this one system, and instead keep going, they might try to go laterally or go back and then use a different account to get into other pieces of the system, and then piece those together. So it's a big web, and interactions are all over the place, and it's not just this lateral line that we go through. You guys remember SolarWinds a couple years ago? I mean, that was a thing. 18,000 orgs. This was a sophisticated attack because they didn't even get in the source code. It wasn't the source code that got breached. It was the build system. So people looking at the code, oh, that looks fine. But the build system injected a signed DLL. So peer reviews didn't catch it, really, right? Looking at our package versions doesn't catch it, really. But scanning the binaries might have caught it. But yeah, it went out. And then they started like getting credentials and exfiltrating and doing additional stuff. It's a different way of thinking that, like, are we doing defense in multiple layers in multiple parts of our system? It's lateral thinking. So let's start at the beginning. Initial attack, initial access and credential attack. What are some things we could do? Well, there might be vulnerabilities in our application. Again, I said there might be valid accounts that they got through some way. Maybe they're brute forcing, or you know, they've done some phishing to get valid accounts. All of these are different ways, you know, your classic exploits. So maybe we're talking about SQL injection. Like, we've all seen stuff like this. We just add a little bit of SQL at the end, and because we're adding in our user ID right there, we get some SQL injection, and it does some things we don't expect it to do. And it goes, yep, that's true. You're a user. But we know this from decades, literally, of OWASP, right? How do we defend against it? Well, we know this also from OWASP. Parameterization, like start doing parameters, validating things, looking for weird stuff. What about brute forcing, credential stuffing? Have we thought about saying multiple accounts from the same IP and just trying to do some detection? Do we even know if the same IP has tried to log in with multiple accounts over a given time window? Like Entra or whatever your identity provider might tell you, but at the application level, who's looking at that regularly? One hand, maybe two. What about rate limiting? Hey, you're trying to log in a lot. Yeah. One or two hands. So this is detection. Like, maybe not, like just knowing that that's happening. Would you do something to your application if you saw that? Would you maybe block an IP or implement, like if you saw that? That would worry you, right? If you saw those type of behaviors. That's behavioral detection. Like your code is working properly. It's not letting the account in, but it's the behavioral aspect you might be missing to tell you you're under attack by an attacker. What about execution? Code injection. Well, we could try to do OS command injection. That's something that people do a lot. Maybe client-side scripting, injecting into processes. So there's a lot of times people will invoke sub-processes in their code. So maybe they're like, I need to convert this thing, and I'm going to invoke a command shell to invoke that process. Like, oh yeah, I've got GraphViz on my machine. I'll make the diagram. There's nothing wrong with that, right? Unless we put maybe a semicolon and say, wipe your file system. That all gets passed right in the CMD, and it'll do both. Nothing bad about that. The other way you could do this is you could say, I want to do process start info, know exactly the executable you're invoking, and give it the command arguments. You're not invoking a shell. You have maybe and I would actually add an additional step potentially on, like, validate the hash of the executable before you invoke it. But like, this is a way you can more safely, like nothing's ever 100% safe, but more safely invoke an outside process without going through a command shell with all the globbing and interpretation rules of the command line. What about unsafe deserialization? Like, there's a reason, like, .NET kind of stopped using the bin serializer a while ago. Like, we serializing objects is hard when you don't know the shape of it. Like, this is using pickle, but like, if you're just deserializing something without validating your schema, like, is this actually a valid object? Yeah, like we've seen vulnerabilities with things like zip and decompression, where you could have like a 1K file that when you unzip it, it's 4 terabytes, and it's just a loop that fills up your whole hard drive. It's hard to write logs and detect when your hard drive's full if you don't put some limits on these things or try to detect these things or pay attention to these things. So there needs to be guardrails. The deserialization is one of the main ways people will try to leverage the 1203. Like, it's definitely an entryway for a lot of systems. Like, that's why we implement fuzzing on some services, to check for inputs, check for if you're detecting size and detecting valid schemas. What about persistence? We've got an in there. How do we keep going? Well, maybe we try to modify accounts. Maybe we adjust our session timeouts. We reuse old stuff. We do things on the server, like we maybe upload a file that's a picture. Nothing bad there. So maybe you just have using a session, and maybe you don't have all the right settings, or you have a really long time, or you're not saying HTTP only. Like, there's different options here that you can configure to secure things a little bit more, because like, if you're not rotating your session and you're not validating it, that's another way that someone can try to exploit it. You might have some really strict settings. You might have some really short times. You might even generate fingerprints. So if the machine that I'm on has a certain browser and screen size and fingerprint, and it's different from yours, and you get my session because you're sniffing in the coffee shop, it won't work for you. Like, just extra little layers, little things to add to help prevent. It helps a little bit. Who allows attachments on their websites? They allow people to upload files of some kind, a document, an image, an avatar. Do you check the content, or do you just check the file extension? Because what if I upload an image that's on your website, but inside of it's really not an image. It's a string or script or a web shell that once you have it on your website and I can then execute it later, by hitting that URL, I can invoke a web shell. So maybe we do detection. We look for scripts strings inside of all uploads to try to check for that. Like, who scans every upload with antivirus and detection and content? Okay. A lot of the same hands, but not as many. Another way attackers can get in. Something to think about. Especially always visible uploaded content. It's like, huh, cool, you let me upload a web shell because I said it was a doc or a PDF. Credential access. So, how long did you, who's played with OpenAI or Claude or Gemini or any of those? How many samples did you see that said, oh, just put in your API key? Who's done like a course on Learn or on Microsoft or any of those where it's like, hell yeah, just make a storage account, grab a token, plug in the value here. Has anyone seen those? Because we don't want to talk about security while you're trying to learn the thing, so we teach you the bad behaviors because it's easier than going, let's stop, let's talk about security. Oh, let's talk about scalability. Oh, let's talk about resiliency. They just want you to invoke the thing. And I've given feedback to the Learn teams on this in the past. Like it's an education problem. But in almost everything, you're going to see maybe, how do I make a connection string with an embedded password or an API key? How do I do this thing? Like, where's my bearer token? Or I want to interact with ADO. Let me go get a PAT. The personal access tokens. Same with GitHub. That is the same as you logging in. If someone has your PAT, they have your identity. They can do anything you can do. Like, and so when I see these things in .env files, in code, in app settings, JSON, like, what we should be doing is if you have to store something, and I don't even like having secrets of any kind anymore. I'm RBAC all the way, managed identity. I don't want a password. I don't want a secret. I don't want a certificate. I don't want any of that. But if you absolutely have to, you should be using something like a key vault and access it locally in dev, default Azure credential. But in prod, don't use default Azure credential. Because technically, default Azure credential checks for the AZ CLI environment variables, AZD environment variables. It'll check for all sorts of things, and at the bottom, it'll check for managed identity credentials. So I actually have in all of our code, and this is actually guidance from Microsoft. Dev, default Azure credentials, fine. You should actually detect your environment and in prod only allow managed identity credentials. Like, don't let it go through this try-catch block of like 5 choices, because if attackers know that, they're going to try to inject environment variables into your solution and override your identity or steal it. But using these type of credentials, these are the ways that I think are good to access the secrets if you have to. Like if they're running on a trusted platform, like in a cloud, and you're doing federated credentials where it's not something anybody can steal, a certificate, a password, or whatever. It is who your identity is running on this platform. That is just one more level of security. It's harder to breach. But you can do it in JavaScript. You can do it in Python. You can do it in C#. All of these work with managed credentials, managed identities. Now, if you're on GitHub, and I think GitLab might do this, ADO can do this now, secret scanning. Like, GitHub has had for many, many years now, secret scanning. So if you push your AWS key, your Azure key, your whatever key, and there's like hundreds of patterns, like 200 plus, they'll be like, hey, you checked in this secret. But they have push protection now as well, and you can enable this on stuff where it's a pre-commit hook, or it's a pre-push hook. So like you have it checked in locally, and you're trying to push it up to GitHub, and it goes, hey, I got these files, and you checked in your secrets, and it's going to be public. Let's not do that. Like you can stop that. And you can also like work on this locally. You can start adding hooks into your own repos to detect if someone's checking in secrets. Or like there's Git leaks, there's Trufflehog, there's some other ones. So like if you're leveraging GitHub or something like that that has these, turn that stuff on and make sure it's enabled. If not, look at doing some pre-commit hooks in your own repos so that the people running, like at least maybe will catch themselves. On the .NET space, I usually tell people use user secrets so that it's just like outside their repo so they won't commit stuff as well. Defense evasion. So we're in there, we're rooting around, we're doing stuff. We don't want to get caught. We don't want them to pry us out of the system. So, attacker techniques. Maybe we want to hide things, hide information, or mess with logs so they don't see us, or audit trail, or hide the fact that we did something and look like it's legitimate traffic. So maybe we, instead of like just having a log that says, hey, there was a failed login account, what if we also try to add this was successful as part of our username? Like if you're investigating that, that would be really weird. Like it might log, oh, successful login for admin, failed login for admin, that's weird. It might obscure the fact that someone got in or was trying to get in, and you might just spend a lot more time researching this. Just kind of muddies the waters. What about messing with, or trying to prevent messing with log entries? So we want to do stuff like, we have a secure log entry. Maybe we're putting it out on a custo table, or we're putting it in a secure storage account, log analytics, or write-only type of media, and we're using like maybe a hash to show like this is our legitimate thing. Here's the details of the event. So we're separating just building strings into building real defined objects. Like, I'm not saying it's like, this is easy to do, this is a little bit more work. A lot of us will start with the easy step, but like as you start thinking about it, start up in your game. Like, let's focus on the detection. Focus on maybe having a SIM and an immutable store. So, you got some sort of logging and validation. And you might have your local buffer, but you want to send it out of your system. Open telemetry is a great, like you can leverage open telemetry. They're working on open telemetry audit. Like those things come into play, and then you can look for tamper detection. You can have alerts on this stuff. You can be aware. Remember, I said a lot of this is behavior detection. This one's come up a lot. There was actually some videos about this recently. I think a lot of us have heard of supply chain compromise. I mean, you could just go back to LeftPad back in the day. That wasn't even a vulnerability. That was just, I'm done with ungrateful people. I'm going to take my package and go home. Oh, I broke the internet. Remember that? Nobody could build or deploy anything because it was just needed. But what if we actually try to compromise upstream dependencies? What if we actually try to make malicious packages? Event stream, 2018, 8 million downloads. But if you had Bitcoin, that was nice. What about Shai Hulud? Do you guys remember Shai Hulud from just last year? That was all over the place. They got into like 1 or 2 packages, and it had a script, and it looked at if you were a maintainer on other packages and added that into those other packages and published new versions. Like it spread, and it would like, it was bad. It was all over. What about oh, you're not seeing what I'm seeing. That's weird. Give me 1 sec. Okay, there we go. Remember, I said it was in a browser. I had updated a slide, and I saw it on my speaker notes slide, but not you. So, Shai Hulud. There we go. Self-replicating. I did a pull request before this. Typo squatting. This one's fun. You know, you just kind of Google what the package is, or the AI figures out what package you need to build the thing. Nobody does that, right? Nobody's just like, hey, I don't know what package to get for this. Go grab the latest package for blah, 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 blah to help me do it. In Python and .NET and Node. I've never done it. Looks good to me. Push. NuGet. So in Microsoft, we use artifact feeds from Azure DevOps or private feeds in GitHub. And we have to have a NuGet config or an npm config or a pip config in all of our repos because we have to go to artifact feeds. We cannot use public packages. And the reason for that is we want to make sure that if we have a package, it's pulled internal, we scan it, we validate it, and we look for this stuff. That's why we weren't really hit with Shai-Hulud. Like, we were looking at the packages before we pulled them in. But it's very easy to go, what if someone tries to guess at the name of a package that might be used inside your company? Like, oh, I want to have secure logger. You know, company name.secure logger as a package, and I just throw it out on npm and wonder if the resolver grabs my package instead of your package. That could happen. And it just doesn't log things. Compromised base images. I'm sure that you are aware that you probably got to rebuild your images like every other day, at least every week. There's always a new CVE on the base images. There's always a dependency or package inside of a base image that gets compromised, and there's people out there with containers running for months. They're not 0 days. They've been known for months, and they might be able to compromise you in some way. Who followed this? Who followed XV? There actually was just a really great video by Veritasium all about this. It was like an hour-long video on how the internet almost broke. And it was literally a guy at Microsoft working on the Postgres team that found it because he noticed his SSH logins were a half-second slower than they used to be. It's like just a fluke. Like he's like logging in, he's like, huh, and he looked and there was like a change and like dug in. And this is a like 2-year time investment. And in the video, they go really deep into this, but essentially it was like one maintainer or just a small number of maintainers on this project. And this person, Jaitan, started helping, adding tests, helping out, responding to issues, being a good citizen in the open source space. The goal was to compromise XV because XV was a part of the supply chain of OpenSSH. So everybody who tries to go remote access on a device, routers, servers, whatever, OpenSSH, FTP, like file transfer, all of these things are built on top of that. And slowly started having more control over XV, started adding junk files. XV is a compression library. So occasionally there's junk files in there because it's like, I want to compress this. I want to decompress this. This should be the same. Added some new junk files. You know, the goal was to be included, the new version of XV to be included in Fedora, Ubuntu, and CentOS. The OSs that everybody out there uses for all sorts of things. It was in some base versions, trial versions, you know, like canary type builds. And that was the build that the Microsoft researcher was using. He was using a pre-release version of Ubuntu and noticed this slowdown from the previous version. So it was this long, slow burn of like almost 2 years to do this. And like there were some failing tests with like, hey, this is doing like a weird hook in memory. Like disabled some tests. Oh, I'm just trying to fix the test. Don't worry, I'm just gonna turn them off for a little while. Yeah, like this could have been in pretty much every OS everywhere with like backdoors. Essentially, if you tried to authenticate and you sent the right signature or right little bits, it would just not do the cryptographic verification. It wouldn't check for certificates, wouldn't care if there was a man-in-the-middle attack. It would just pretty much let you in if you passed it the right key. So OpenSSH would have been open. which was the goal. Yeah. Maintainer takeover, supply chain compromise, obfuscation, remote code execution. All because some guy was like, half second slower. How many of you notice a half second? Now, he was doing performance on Postgres, so he was probably really obsessed with half seconds, but most of us, the rest of the world, nobody knew. Nobody caught it. It was because it was doing hooks in the Linux kernel to like override the code table. What about, who uses package locks on all their stuff? Who uses SBOMs? Who's like looking at the versions and hashes of their dependencies, going, hey, this version last week is different than this version this week, same version. Couple of hands. We should be. Like, and there's different, like even with NPM, there's a difference between CI and install. Like we want repeatable builds and validatable builds. So we have different ecosystems where we can verify and we can do things with the packages. And again, SBOMs and lock files help with this. What actually went into building your system? Do you have the hashes of the things that went into building your system? Do you have the exact version of all of those dependencies that went into building your system? This is a great way to find those out. So, supply chain compromise, execution, unsecured credentials, valid accounts, account management, or manipulation, exfil. These are things that they go for when they're going after your supply chain. But we're updating all our dependencies every month, right? We're safe, right? We did the checkbox. Were you thinking about all the other things? So, what else? Now they're in. Now they've got it compromised. What are they going to do? Well, maybe they're going to get your data. They're coming for your data. Maybe they're going to take over things. I don't want to pay for storage. I don't mind if you fitting the bill if I upload files or use your compute or mine. Maybe I just want to take it all the time. So, who looks at regular usage? Like not just the request per minute and rate limiting at the API level, at the customer level, at the account key level, but also look at, you normally do these pages that query 10 or 100 rows at a time. You're querying 10 million rows. That's weird. Maybe. So maybe you're looking at records or tables. Maybe you're looking at sensitivity. There's tools out there to help with this, like Purview at Microsoft. Like there are tools for digital rights management and protection of these things. And if you're not leveraging, you might want to. But those a lot of times work from a SharePoint, OneDrive, like Teams type of view. You might not be thinking about it from, we have a CRUD app on top of a database. So what if someone gets in your network and gets to the admin CRUD app and just starts downloading everything? Would you know, other than they logged in and they did a query? Would you know how much data they queried? You might not. So like just thinking about something like that. And of course, API rate limiting, that's a relatively easy one. We can maybe look at the bytes they're transferring or the size of the thing, not just calls, but maybe records per second, something that you can try to think about if your application doesn't have that normal bulk behavior. You're starting to see that sort of bulk behavior. That's weird. And you might be able to correlate that with throughput or CPU or something else. Like as you start putting all the pictures together through telemetry, through logging, through metrics, again, more data is better in the logging space. So how do we monitor this stuff? Again, we might have a user request. We authorize. Maybe we look at their data access. We have a monitor that checks what you're doing or why you're doing it. And we look for anomalies. If it's an anomaly, we can block it. If it's not an anomaly, maybe we then look for, that's a valid query, that's secure. but you're doing a lot of transfers. That's an anomaly. Or you're doing a lot of things back to back to back to back. Oh, that's an anomaly. So like building this in, checks before and after. It's super easy to say, oh, I got an API management, I threw it up there and I put a rate limit on it. Everybody has an account key. Who looks at that stuff? Who bakes it into their code more? Who has alerts through OTel on some of like the data transfer coming out of their systems? Attackers hope you don't. Makes it easier. And maybe you think that your site's not worthy of being breached. Go look at have I been pwned. How many of those sites are not always the really big ones? Sometimes they're not. Sometimes they're smaller ones or side ones or community things. So let's look at some practical implementation. When we want to build a new feature, I think part of the thing you should be doing at the table is going, how would someone attack this? Could someone maliciously take advantage of this feature to do something? Is there risk to the existing implementation by adding this new feature? I worked with a e-commerce site that had gift cards, and you could check your balance. I don't know how many of you can see where this is going, but you had to have a number and you had to have the bin code with it. You always needed the 2 bits of information. Well, there was a redesign. They just let you put in the number without the bin code. We noticed a spike in traffic on that endpoint, and we saw them sequentially checking every number. And we stopped it very quickly, like within, like we saw some alerts go up on usage and traffic, and we're like, huh, and we looked, and then we just turned the endpoint to just always return invalid thing, because what they were doing was they were not only getting the balance, they were finding out that it was a valid number or not a valid number. I helped solve the problem. I didn't help cause the problem, but like I recognized what the problem was. Someone could just sit there and run a billion numbers and go, hey, cool, $100, $50, $25, $50, nope, next, and just keep going and find patterns. And then just go steal the money and sell it on the black market. They didn't think like, huh, is there a risk that, you know, it looks cooler with this UI design without that second box there? Is there an implication of that maybe? Like, is there a reason we need that there? Yes, there is. So, like for each new feature, maybe we talk about MITRE ATT&CK a little bit. Maybe we think like an attacker and go, could this be used for evil? Could this be combined with something else? Like, would this let them get into our system? Could we maybe detect that? So notice it's not always about the blocking it. Sometimes it's just what behavior could this enable? And can we detect that? Like that's a good start for a lot of people. Can we detect that and implement it? And you can validate that. Like this is something that, again, shift left. Security should be at the table when you're designing features. Everybody should care about security. Oh, user login. Okay. Are there things we can do to detect phishing or brute force or valid accounts? Password reset. Are we going to say, yeah, that's a valid account, we'll send it to your email. Or no, there's no user with that name. That tells information to people. That tells them, oh, cool, I found an email I can attack. I can email the person and send them a phishing email that looks just like your website. How much data are you telling them by being friendly and helpful? Session management. Do you enforce that fingerprinting and short timeout and like TTLs, file uploads? Are you scanning for those things? Like all of these features that you start adding, we want to make a new endpoint. Well, does that let them discover things about our system and do network scan? Like, will we get information routed out, data export, logging, dependencies? Do you guys have detailed discussions when you add new dependencies to your app? Or does it just get added? Scans pass, it's good. Yeah, bake this detection into your code. Look at patterns, behavioral patterns. And if you're starting to think about MITRE, start including those IDs. Like, your security people will love you if you do. But like having something like, oh, they're doing bulk, export here. Like that in your logs, like it makes it very easy to make reports to see how people are interacting. Think about risk. Think about like we've enabled that for Entra. Like impossible travel is the easy one. Oh, you're in Florida, now you're in Oslo, and that was 5 minutes apart. Not really, many hours. But if it was 5 minutes apart, that would be kind of impossible. But maybe I'm hopping on VPNs. Okay, why? Like, where are you really? Like, honey tokens. Like, honeypots are fun. And having good logging. Always use defense in depth. So, prevention. Again, lean into OWASP for some of these, but input validation, authentication, authorization, data access controls. Don't just give everybody keys to the kingdom every time. Like, least privilege is a thing. Don't trust anybody. Zero trust. Don't trust me. Don't trust anybody. Detection. Look at the behavior. Look at how they're interacting. Look for anomalies in your system. Try to understand the threat intelligence. And that's more of an advanced thing that comes, but if you're using a SIM or other automated system, something like a Sentinel, that can help. And then maybe do automated blocking or at least alerting so that you can remediate those things. And again, these fit into each other. We get secure coding that gets us secure by design so we can do some behavior monitoring. We've got vulnerability testing and technique correlation so we can look at the behavior. We've got security reviews and threat hunting so we can leverage that with some automation. These things go together. So, what are some places in your system that you can start leveraging these? So, SAST and DAST. So we're doing static analysis or dynamic analysis. We can look for vulnerability scanning. So we can look for code patterns. We can have logging for security events. So we can start tracking with MITRE. We can do a risk assessment. Like I have to do a risk assessment on every one of my services like every 3 to 6 months. Like we do it over and over again. It's not a one-time thing. It's a continual thing because the landscape is constantly changing. Like we learned from SolarWinds, we learned from XV, we learned from Shai-Hulud. But it's easy to fall for those things if you're not paying attention. So you have to constantly kind of look at what the landscape is doing, what people are doing. Do code reviews, look for vulnerabilities, do pen testing or incident response. How you handle operations and how you handle what happens if we're being breached is just as important as trying to prevent it in the first place. Look at all these things. So, if you're just getting started, start thinking about detection and mapping, and some base analytics. Then maybe start looking for anomalies and response in your systems. You got to have that baseline of what are people doing. Have some behavioral data. Have a better logging framework, better auditing framework. Like just try to check for those things and try to identify those behaviors that you can that indicate that someone's trying to attack you or do something that's weird. Thousands of logins from an IP or hitting different endpoints in weird ways. And then there's more advanced stuff you can do. But start with the basics. Have some training workshops. Again, in your designs, start talking about how would someone exploit this? How would someone come at us to take advantage of this? There are some tools, Attack Navigator, I'll bring up the website in a minute. Just have a better culture of security and maybe red teaming at your organization if you don't. Look, like I said, detect. Look at the metrics of what's happening. And start seeing if you can collaborate. The security team shouldn't sit in a corner. And dev team shouldn't sit in an open floor plan either. Nobody should sit in an open floor plan. Don't wish that on anybody. Managers out there, it doesn't work. No open floor plans. So there is this thing called Attack Navigator. You can go through and you can look through the different layers and tools. They actually have a lot of great tools out there. You can look at defenses, the techniques. You can talk through different controls. It's a really interesting website. I would say pick 1 or 2 techniques to go after. Maybe, have really good authentication monitoring. Have really good session. If you have an interactive web app, look at your sessions. These are front door stuff. Look at weird anomalies with data collection. These are like the big hitters. Like once they get in, they take data. Cool. So look at how they're getting in and look at how they're getting data. Like, cool. We could do all the other checkboxes, but that's what they're going to do, it potentially in your system. So eat the toad in the morning. High impact, relatively easy, immediate value. You might see in code bases to do, add this check later, fix this, maybe rotate that. We were having a conversation out there about certificate rotation. It's hard. Sometimes people forget to do it, and then sites go down. Or you rotate it, but you rotated it wrong. Or you forgot a service. Or you don't check for certificate revocation. You don't check to see if it was valid at one point and is no longer valid. So someone could be compromised and you're talking with them thinking you're secure and you're not. Don't leave it to to-dos. Like start tagging things and talking about how it might be taken advantage of. Start thinking like an attacker in what you do and how you interact with your teams. So, some key takeaways for you. Leverage OWASP, but also leverage attack. Think about not just the check marks and doing the things, but how people are going to interact with your system. Think like an attacker a little bit. Try to, think like war games and talk to Joshua. Just find backdoors and how someone could take advantage of your system. It might be a low probability thing, but if you go, we don't really check that thing over here because we assume that. What are those assumptions? Document those. Like, find them. Start building detection into your code. Monitoring is not just about CPU usage and disk space and web requests on the container counts. Think about if you were looking into a breach, how you would audit that. What would be the data points you would look for? Make sure those are being recorded. Get a little familiar with these technique IDs. You'll start, like having a common dialogue and a common language helps. It really does. It kind of stops muddying the waters. And then start looking at behavior. And again, start small. Pick 1, 2, or 3 techniques that are scary, that are used a lot, that are high profile, and dig into them. Again, I'm Chris Ayers. Feel free to reach out. And I will, after this, I'll actually bring up the attack framework website. But we have a couple minutes if there's questions. But I'm going to go ahead and just let me do this. Come on, where's the mouse? There's the mouse. I don't normally duplicate, so I want to fix the recording. We want 1080p. Makes it prettier. There we go. So, this is MITRE ATT&CK. Notice, if we go up here, they actually have for mobile and ICS. So there are different matrices that you can look at with different techniques for different types of devices that you can dig into. And you can even look at like things on Windows or Linux or cloud. So there's a lot of good techniques here, and I'll zoom in a little bit and kind of scroll down. So just like we talked about with initial access and execution, persistence, you can come out here to MITRE and just dig into these and look at these, abuse control mechanism. And they talk about it, they give you the sub-techniques, so you have the main technique, you have the sub-techniques that you can dig into and look at these. This is a really great way, and then like, here's some examples. And here's some mitigations. And here's how you can detect it. So you don't have to go into this alone. Like, a lot of this research has been done and gives you a way that you can start digging into some of these and have a little bit more of an understanding and educate yourself. And this can be something that you can link to in your documentation, in your operations plans, like in your planning for features. So, Thank you, guys. And again, if you have any questions, I'm here, but I appreciate it. Anybody got a question? Security folks, did I screw it up? I consider myself a dev more than anything, or, yes, question? Yeah? So how would I convince management to do this is the question. So I mainly talk about resiliency at work. I actually work on Azure, and I focus on resiliency. Every single time I have given a resiliency talk to a customer that's never had an outage, they go, cool, can we have one instance? Can we scale to the smallest possible? Let us save all the money. As soon as I talk to a customer that's had an outage or a breach and they realize it costs them millions of dollars every hour they're not running or for data loss or something, they go, okay, cool, can we have 5 instances? Can we scale it up to premium SKU? Money's no object. Because while they're operating, it's insurance, it's protection. So how much is it worth to your organization if all of your data was stolen, your websites were taken, your code was silently stealing credentials and sending it to an outside attacker for months? How much is that worth to you? No, I am not saying create your own incident so you justify it. That has been the plot of too many movies. The guy shouting into the void, why won't they listen? I'll show them. No, don't do that. That is not what I'm advocating. But point to the data from SolarWinds. Point to the data from Shai Hulud and XV on the man hours it costs to fix those things when there may be some detection or some SAST and DAST scanning would have prevented it. Look at the statistics from OWASP on these vulnerabilities have caused this impact to the organizations like ours and to the industries like ours, and go, we can do that, but then we can add this one little layer of protection by just spending an extra 15 minutes in our meetings talking about how attackers might approach our system. Back it up with numbers. That's my recommendation. I hope that helps. Any other questions? All right. Again, thank you guys. I appreciate it.